Hi, I'm Jim Grouch of METSIM Proprietary Limited, and in this video I want to show a short segment of a demonstration video showing data connectivity between a dynamic METSIM model and a 3D walkthrough system and SCADA. So it shows how METSIM can be used as part of an integrated system. So what we see on the screen at the moment is the first page or section of a dynamic model that's been built to match instrument for instrument, line for line, drain valve for drain valve from the PNIDs of the process plant for which this model is built. And we can see that there are a number of instruments, and the instruments are used to connect to tags for the SCADA system. So I'm just going to show you a short segment of the demonstration, part of the demonstration video, and it's a little bit screechy, I'm afraid. Maybe I was a little bit too excited when I was doing the commentary for this, but it's done. And I think it's useful, so let's watch this for a while.
Well, let's go back to that flow meter. So back on the middle screen.
So we're in the 3D model, and now we can see the interactive PNIDs.
Then there I am again. But now I'm going to left.
And what we just did was we jumped from somewhere in the PNID into the 3D model.
I would like to interact with that flow meter. In other words, if I were there in real, I should be able to walk up to it and see the local digital display on the side of the flow.
So what this shows is that from within the 3D model, we can right-click to see a display of the instrument, and we can interact with that instrument in the 3D environment.
Interactivity. So what we have here is a simple display, as if it were a digital display.
And very shortly we will start the dynamic METSIM model, and then we'll see that from the interactive PNIDs we can change valve positions, etc., and see the dynamic values change in the 3D model and on the 2D
for that
schematics.
Flow meter, it's also 64. And if I were to click on it and change the number, and I can do that because the dynamic model is not running, and look back into the 3D model, I see the number has updated there. So we have complete interactivity and data communication between the instruments in the interactive PNID and the display in the interactive 3D walkthrough model.
So this is all done using METSIM running dynamically in the background as a hidden service, and using our own programming and linking with DLLs or dynamic link libraries to provide the interconnectivity. Now we're going to start the model.
Button grouping at the top. I'm clicking on the Area 210 button, and although there are many options there, I'm simply going to start the model. I have some choices of whether I start it using a previously saved scenario or just start it from the original model as it is currently, and I'll choose that. So I'm chosen to load the model directly without choosing a particular scenario. I see a message to tell me that the model is loading.
What this shows is that a SCADA is being used as a graphic user interface and is being used to start and control METSIM, start and control the dynamic METSIM model, which is running in the background.
And in the top button, and I can see there's a number which is iterations.
This is quite a complex dynamic model. As I said, it includes all drains, it has reverse flow, things can overflow and go wrong, things can be broken, and the dynamic model is running at a iteration speed of 1.5 seconds, which is good enough for the
We
update
some may
rate
believe
of the
is
SCADA
not
screens.
very fast. Some
This
simulators
shows
can
the
run much
3
faster,
screens
but in
with the
reality,
3D
it's
walkthrough
more than
model, the
sufficient for
two
training requirements
2D PNID
where typically the
diagrams,
process
and
control
also
system screens are
a
only updated
commercial
on a 1
SCADA
or a
system,
1.5 second interval in any case.
another commercial SCADA system.
Now we have the process model running and the numbers being generated in the instruments are directly related, are the numbers that are being generated by that mathematical model. I'm going to go back and again to the Area 210 model menu button. I'm going to put all of the controls onto manual.
So everything within the dynamic METSIM model can be set and controlled from this SCADA interface. So obviously an important functionality is to set all the default values for a very complicated model, and that is, if you could do that on a real plant, it'd be fantastic. And you just say, set up the plant for normal operating conditions. Obviously it's not that simple, but in a digital world we're able to simply set the default values.
Disconnect this so that it provides...
Now I'm setting this PNID controller to manual so that I'm able to change the output position of the valve, and I'll see the flow rate change.
And now I'm able to input a value such as for the position of this control valve. And when I made that change here to now 30%, I can see that the flow is now coming through at 128 meters cubed per hour. And if we remembered when we went into the 3D model on the left-hand side, the flow was 64 previously. It's now 127. And you can see that there is a complete interactivity.
So what we're seeing here is that METSIM is receiving the control valve output position value from the SCADA system. It's using that position in the dynamic METSIM model. It's calculating the flow rate based on a simple pressure network calculation. It's calculating the flow rate for those conditions, upstream and downstream, and it's providing that dynamic value, as you can see level changing here and other things changing, and it's providing those dynamic values back to the SCADA system onto the live PNIDs, and is also providing that data into the 3D walkthrough model.
Able to drive the plant and see what the consequences of all your actions are. Because I've been pouring water into this hopper, we can expect there are no pumps running, the suction valves on the tank are all closed, and therefore the level in the hopper is 100% and it will be overflowing. Now in a simple schematic like this, there is lots of information that you simply cannot see. It won't be shown on the control system because there is not a flow meter on the overflow. But if we wanted to see additional information...
This introduces the concept of virtual instrumentation. Additional information is calculated within the dynamic model, is not available for any other instrumentation, but can be displayed as additional information.
The .meteng.com.au button, and the idea here is Meteng gives you additional knowledge, and when we click on that, a number of red virtual instruments appear on the page. And I can see on this hopper where we're pouring in water at 255 meters cubed per hour, without taking anything out, that it's overflowing at a rate of 261 meters cubed per hour. It's not quite balancing. There must be something coming in from somewhere, or the instruments are not perfectly calibrated.
Okay, I'm going to stop the demonstration video at this point. So the important thing here is we're seeing a live dynamic data connectivity between a METSIM model that is being started and controlled from a SCADA system. The information is being shared across to a walkthrough 3D games like environment, and this is being achieved with a overriding program that we wrote using DLLs and using OPC connectivity. But the point here is it doesn't matter. There are many ways to implement this, and I wish you to see that METSIM is an ideal platform for part of an integrated system for use with dynamic modeling. And the METSIM capabilities for dynamic modeling go as far as you would like them to be. So as I said, in this case, there is a pseudo pressure network with flow distribution according to downstream valve positions. Tanks overflow, pumps can break, valves can have characteristic flow conditions, etc. But I think that's enough. I might show some other short segments of this demonstration video later. Thanks for your time.